Hello guys, welcome to Ramta Solutions and welcome to your lesson on written analytical geometry. Today we are looking at distance between 2 points. So at the end of this video, you will be able to know how to calculate the distance between 2 points. So in this video, first thing first, we're going to derive the distance formula and conclude this video by giving you some worked examples which can assist you in using this distance formula. Remember, we're saying that we are dealing with distance between 2 points, so it does not matter. If we want distance between 2 points, we are going to use the formula that we are going to derive at the end of this. Okay, so let's see. Without any waste of time, let's get into it. Now, we're going to derive now the distance formula. Okay, we're going to derive the distance formula. So, we will say, and let's say we are given 2 points, and those points are, let's say A with coordinates x1, y1, and B with coordinates x2 and y2. Determine, giving 2 points x1, y1, and B, x2 and x2, we can determine the distance. All right, we can determine the distance between these 2 points. We can determine the distance between these 2 points. Okay, we can determine the distance between these 2 points. So what we are going to do, one, I'm going to say introduce a Cartesian plane. Let me draw a Cartesian plane. So I'll say my Cartesian plane is like this. Okay. Now, let's say now may need to move it. Okay, I may need to move it. Yeah, let me put it here. Okay. So now I want you to look at this. Let's say now we have a point A. Let me say A is here. Let me say A is here. Okay, let me say A is here. What were the coordinates of A? They were x1, y1. And then let me say B is here. What were the coordinates of B? They were x2 and y2. So we are looking for the distance between these two guys. Let me join them. I'm going to draw a line again. So we're looking for this distance. All right? We're looking for this distance. Now, something that I want you to notice is this. I can somehow say I have, let me draw broken lines. All right? Can you see that? I'm going to draw another broken line. Can you see that? Now, this. So now, this point here is what you call, rather is your 90 degrees. Maybe let's call it point C. Okay, maybe let's call it point C. Okay, maybe let's call it point C. Now, what are the coordinates of point C? What is the x value at point C? Oh, it looks like it's the same x value as that of point B. So it'll be x2. What is the y value? It cannot be the y value of B, but it is the y value of point A, which is y1. Can you guys see that? Now, as you can see, these were horizontal and vertical lines. So this therefore becomes a 90 degrees. So we can use Pythagoras theorem because with this triangle ABC is a right-angled triangle. So we're going to use Pythagoras theorem. Which one is the hypotenuse? It's AB. Okay, So according to Pythagoras theorem, we know AB squared equals, what are the other two sides? Let's say AC, okay? We'll say AC squared. And what is the other side? It is BC, isn't it? It is BC. So what is this? This is Pythagoras. All right, guys? This is Pythagoras. Okay? This is Pythagoras. Okay? Now, so far we do not know what AB is, right? But let's see. We said we're looking for AC. Now, I want you to see now, guys, that AC, when you look at it, it's this x value minus this x value. All right? Points on the same horizontal or vertical line. You can just say maximum minus minimum, isn't it? So the biggest is this point here, x2, isn't it? So it'll be, maybe let me do this. It'll be AC is x2 minus x1. Now let's focus on BC now. BC, where is it? BC, what is the... This is a vertical distance. So with a vertical distance, the highest minus the lowest, isn't it? So this is y2 minus y1, isn't it? This is the distance here, isn't it? y2 minus y1. So BC is y2 minus... So we can say AB squared equals, maybe let's put them in brackets like this. Okay, maybe let's put them in bracket like this. Okay, AC equals, what is, AB squared equals AC squared. What is AC? AC is x sub 2 minus x sub 1 all squared. What is BC? BC is y sub 2 minus y sub 1 all squared. Oh, we are looking for the distance AB, not AB squared. So what do? We will say this will be a square root, right? It'll be a square root of what? Of x sub 2 minus x sub 1 close all square plus open y sub 2 minus y sub 1 close all square. So this is your distance formula. Okay, so this is your distance formula. So when we conclude this distance formula, say for distance AB, you can say this is x sub B minus x sub A all square plus x sub, sorry, y not x, y sub B minus y sub A all square. If you write it like this, it's okay. But what I want to say generally is that distance is basically the square root of x sub 2 minus x sub 1 all square plus y sub 2 minus y sub 1 all square. Of course, the square root of all these. Okay, so it depends. When you are given your distance, remember, generally distance is this. So if you're given, say distance of AB, you can begin with A, you can also begin with B. It's totally up to you. But if this is A, say it's x sub A, here it must be y sub A. And do not interchange them in any way that will confuse you, okay, or in any way that will not give you your desired results. If you begin with A, it must also begin with A on the y. If you begin with B on the x, it must also begin with B on the... Okay, so this is how you use your distance formula. I repeat, if you begin with A on your x's, you must also begin with A on your y's. If you begin with B for the x's, you must also begin with B for the y. So generally, this is your distance formula. Okay, generally, this is your distance formula. I don't know why I like writing this I. Okay, so generally, this is your distance formula, and this is how it is. So now we're going to try some examples. Okay, let's see. Now, item 2, worked examples. So now we're looking at the worked examples. Okay, worked examples. So now we are going to say I'm going to say example 1. I think it'll be the most sufficient example. So let's say P with coordinates -1 and 3, Q with coordinates 1 and 1, and R with coordinates 6 and 6 are the vertices, of a triangle. Okay, are the vertices of a triangle. Okay. Roman figure 1. Plot these on a Cartesian plane. Plot these on a Cartesian plane. And join the points. Okay, and join the points. Roman figure 2, I will say determine the length of each side. Determine the length of each side. Determine the length of each, of each side. Roman figure 3, determine the perimeter of the triangle. Okay, determine the perimeter of the triangle. Okay, so I'm going to the next page and I'm going to introduce a grid. Okay, so let me introduce a grid in the next page so we can draw this nicely. So if you guys have a ruler, you can use your ruler, but for myself, I'm gonna use a grid. So let me use a grid. And okay, I'm content with its width. Now, let me introduce my lines. So I will say, let me see, I believe the highest was 6. So I'm just gonna stick to 6 and 6 and 6. Okay, cool. Okay, 6. Let me just this is Y, so it's gonna be 6, 5, 4, 3, 2, 1. Okay, let me change. I think I should say 6, 5, 4, 3, 2, 1. Now 0 will be here. Yeah, 0 will be here. So again, it will be 1. Oh boy, it will be 1, 2, 3, 4, 5, 6. I don't have a negative y value. Okay, it will be -1, of course. 7. So this is x. So it will be 1, 2, 3, 4. Negative, 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 negative. This is 0. Okay, so we had a point P with coordinates -1. Where is it? -1 and 3. -1 and 3 is here. This is point P. And then we had a point Q with 1 and 1. Where is it? It's here. We had a point R with 6 and 6. Here is 6. And here is another 6. Cool. So let me join them. As I join them, so if you guys have a ruler, please use your ruler. So this is point Q, and then this is point R, isn't it? This is point P, and this is point R. Okay, so we have drawn them on a Cartesian plane. P had coordinates -1 and 3. Oh boy, -1 and 3. Q had coordinates 1 and 1. R had coordinates 6 and 6. Right? Perfect. So we are done with question 1. This was question 1, Roman figure 1, right? So Roman figure 2 says determine the length of each side. I will determine PR. Let's begin with PR. So Roman figure 2. Oh, let me go here and remove the grid. I no longer need it. Okay, perfect. Now, Roman figure 2, we're going to look at PR. What is PR? PR, we will say this is x of r minus x of p, close all square, plus y of r minus y of p, all square, close. By the way, the square root of all these guys. All right? So now, what is this? You guys have a calculator, so I won't really need to stress much. Okay, let me remind myself. P was minus 1 and 3, and then Q was 1 and 1, and then R was 6 and 6. So this is the square root of, what is x of R is 6, x of P is minus 1, all right? Plus, what is y of r? Y of r is 6. What is y of p? Y of p is 3, right? So you have calculators, guys. This is 6 plus 1. It'll be 49 plus what? It'll be 49 plus 9, isn't it? It'll be 49 plus 9. This therefore becomes 58. Square root of 58. Can we simplify square root of 58 in any way? No, we cannot. Now, we're going to look at PQ, okay? We're going to look at PQ. So PQ, again, it is x of Q minus x of P, close all square, plus open y of Q minus y of P, close all square. Now, what is this? Y of Q is 1, y of P, sorry, x of P is 1, x of Q is 1, sorry, and x of P is minus 1. So minus 1, right? Square. Plus, what is y of Q? Y of Q is 1, y of P is 3, right? So 1 plus 1. 1 minus 1 is 1 plus 1, which is 2. 2 square is 4. Now, what is 1 minus 3? It's minus 2. Minus 2 square is 4, right? It's 4. So this is square root of 8. Your calculator simplifies this to 2 root 2, guys. Okay. Your calculator simplifies this to 2 root 2. Okay. It simplifies this to 2 root 2. Happy? So this is PQ. Right. Now, we need QR. QR equals x of R minus x of Q, close all square, plus y of R minus y of Q, close all square, isn't it? Now, what is y of R? Y of R, it was, if I remember, it was 6. So it's 6. Y of Q was 1 all square. Y of x of R was 6. X of Q was 1. Sorry, why I keep saying y and x? Yes, it was. And then y of R is 6. Y of Q is 1. So what is this? This is 5. This is 5 square, which is 25. Again, this is 5 square, which is 25, isn't it? 25. So this is basically 50. 50 is 5 root 2. Your calculator will say 50 is 5 root 2, isn't it? 5 root 2. That's your answer, isn't it? Let me write it. I think this will mess things up. So it's 5 root 2. Now, we can head to question 3. What is question 3? Question 3 says the perimeter of triangle PQR. Right. What is it? It is side PR plus side PQ plus side QR. What is side PR? Side PR is, I think it was square root of 58. Yeah, it was square root 58. Square root of 58. PQ was 2 square root of 2. QR is 5 square root of 2. This, if your exam allows you to leave it as 7 root 2, plus square root of 58. If you like, you can use your calculator and say 7 root 2 plus square root of 58 is 71.5152 units. All right, it's 17.52 units. All right, you can say it's 17.52 units, or you can leave it here and say it's 7 root 2 plus square root of 58 units. That is the perimeter. Remember, perimeter is length, guys, okay? So it is in units, okay? I'm saying units here because the question did not say the distance is in meters. It did not say that. So we'll leave it as units. So this is how you calculate the distance. So guys, remember, this is the distance formula. Whether you use it in this form or in this form, at the end, it's the same thing. Okay, so this is how you do it, guys. Now, we've come to the end of our lesson. And by the way, you can get in touch with us, guys, by checking us out on our email, ramtasolutions.co.za. And you can still get a link to our YouTube channel, of course. Of course, this is where you are. You can follow us on Twitter. Oh, right now we call it X, and Facebook as well. You can also follow us on Instagram. Okay. And if you like, you can talk to us via email. On the very same website, you can still click the WhatsApp icon. You can chat with us on WhatsApp. Okay. And we will gladly assist you in whatever question that you may have. And of course, if you're also looking for tutors, you can also contact us and we will assist you. Okay. So with that being said, guys, this is it. I hope you guys enjoy this. See you next time. So, bye-bye.